the metals that we can print here are listed. Majorly 4-5 categories of metal alloys could be steel, titanium, aluminium, and inconel alloys. So these are the different things that we can print. In total, the technology is able to print about 30 different alloys, and at any time in Wipro 3D we will have the availability to print with about 15 different alloys. It could be used for low temperature applications. So alloys like aluminium are used there. But if your application is something that works in high pressure, high temperature kind of a scenario, then we do have super alloys like Inconel, which work really well in there. So the range of alloys that we have are really good. Copper is a new entrant, probably very interesting for all the EV vehicles. And if there is a very specific need for you to print a specific alloy, we can help 3D print that as well. We've put a lot of parts into space and into helicopters, into satellites. The part that you see over here is called the feed cluster. This is India's first 3D printed metal part which went into space. It's on GSAT-19, still in orbit, still working very well. Our journey started with that one certified part, how additive can be used to get good designs, faster designs, and also probably solve some supply chain problems, right? So the same thing, this has been developed by Deloitte. It is a framework of how anybody can adopt AM. So it's specifically for AM. Now along the x-axis on the left you have cases where you do not need to change your, do any changes to the supply chain. Whereas if you go to the right, then you have to make changes to the supply chain. Along the Y or the vertical axis, what we have below is that you can use additive without making any design changes. But if you keep going up, then these are applications where you will use additive by making major design changes. So what I'll do very quickly now is take each part, show you some examples, especially in metal, and then see how it goes. So the first part is called the status, and this I would like to call as trend number 1. So what's trending now with additive and automotive is that you can do a lot of tooling. Tools could be the fixtures, or it could be tools to make the end-use parts. What also falls into this category is prototyping. You can make very quick prototypes, test your design, which will save a lot of cost as well as time when you are in the new product development. So here are some examples which fall into that category. That's part number 1, status, and that's what is trending. In the tools which are used for, let's say, injection molding or die molding, these kind of tools are very popular. We have one particular material called as maraging steel. We call it MS1, a very hard material. And when you make tools with that, with additive, you have an advantage of making these complicated cooling channels which are conformal. Hence, you can make more parts per minute because your tools are getting cooled faster. So some examples of that, but also some examples of the prototypes that you see here. So this is part number 1, status is done. Now we go on to look at the trend number 2, which is also part number 2, that is supply chain evolution. So another place where you can use additive manufacturing is to quickly make spares. So we have here the MAN truck example, truck and buses. They have been making these bronze manifolds, and this is their spares, and they make all of this particular spare only through additive manufacturing. So AM can be used to solve some supply chain problems when probably the vendor who used to make this part isn't there anymore now. He's shut shop and you need these. Or you want it much faster. So maybe there's a long waiting time and you cannot afford that, and then you can simply 3D print this, but of course you should have proved this part before. So that's the second part, the supply chain evolution. and you derive a different set of values in this particular thing. Now, path number 3 is where you start to make really start using additives value addition, wherein it can make extremely complex designs. So here, the design of the part starts to change. So the designers have to be educated, the supply or the procurement people have to be educated about AM, and that's when together they can harness this particular advantage. Wherein John Deere, I think there was somebody here from there, and they have been making these kind of manifolds again with additive. You can make extremely complex manifolds which are much more efficient. So we have been talking about sustainability for quite some time now, right? One way of looking at sustainability is additive a sustainable process, right? That's debatable. Maybe the way the powder is made is not so sustainable, but the process itself is sustainable. But just imagine you design a component that is so complex, let's say like a fuel injector, which will help reduce the amount of fuel that's consumed. It will give you more mileage. Now, if you look at the whole life cycle of the part, Ravi also stressed about this point, right? You can make your parts much lighter. Now, when your parts are much lighter, especially for electrical vehicles, you can have it run more distance, or your motors could be, less rated. That's also again sustainable. The lighter your vehicle, the more sustainable it is. So, additive manufacturing will contribute to sustainability, but then you have to look at the entire spectrum or the entire life cycle of this particular component. So that's number 3, and that's also trending. People are coming up with extremely unique designs. Now here is where we start to get futuristic. Right? We have discussed 3 different trends, but now we start to see what the future holds for additive in the automotive world. And here is an example of UPTIS. So UPTIS is the acronym for Unique Puncture-Proof Tire System, and you don't get a flat tire, and this can only be 3D printed efficiently. So imagine having this on the military vehicles which goes on really tough terrains, and you don't get a flat tire, right? Completely new idea, a very new innovation. Also Helix, they have 3D printed their entire electric van. So innovation is what comes as a value add in the very last part of the business model, right? So you have more and more things coming like this, and this is a Wipro 3D example. Divergent Technologies says design, print, assemble and drive. So design whatever you want, you have a lot of freedom, and then you can print it. You need not go the regular manufacturing route, assemble and drive it. So when I talk about entire components like that which are very huge, there are quite a few technologies that can be used to 3D print this particular component. So in metal, what we do at Wipro 3D is we use a technology called as LPBF, and then there's another technology which prints with metal, really large components, and that's called DEB. So there are quite a few options, quite a few technologies, and a whole lot of opportunities, I feel. So I would like to thank you all for your time, but I would also thank you for this forum and stage. I'm open to take your questions.
Hello. It's a great presentation. I wish if you could show some kind of videos, okay, and that would have been a clear idea what is 3D printing all about. Coming back to your conventional manufacturing and 3D, you said it is sustainable because thickness could be less, this could be lighter. Uh, my question is sustainability is design. If the design is 10 mm and through 3D you are making it 5 mm, and still you are claiming it is more sustainable because it is more green. I don't accept that because the design itself is 10 mm. Okay. In that case, through conventional manufacturing also you can make 5 mm.
Yes.
So what is the advantage of 3D printing?
Yeah. So when I say having lighter parts, it means applying the principles of topology optimization to a certain part. For example, the IIT Bombay project that I showed you where the part was much lighter, right? So what we have done is that we have not reduced the thickness to 10 to 5 as is, but rather what we've done is we have only retained material along the stress path based on the loading condition and the boundary condition, so that the part functions as it should, but it doesn't have extra material that is not necessary because it's not load bearing. So by applying those principles, we are able to lightweight. I will not deny the fact that additive is a bit more expensive than if you would make the part conventionally. But I think, and what we have seen in our experience is that it's about mining the right parts and also looking at the entire business case rather than part to part cost. Meaning, let's say you want 20 numbers for a functional testing or something. If you go to the conventional way, you would spend on the tooling, you would spend time on it as well. But with additive, you get it much faster, so your product is probably launched faster to the market, right? So when we look at the advantage, maybe it will definitely balance out or even better. But when you look at we do some really small components at Wipro, and we make about 7,000, 8,000 per year. That's like a production order for us, and the part is definitely cheaper than a conventionally made part. So it is about us together mining for those correct parts. I'm not saying everything should be 3D printed, even if it can be. It's about finding